Now I turn to another empirical phenomenon, but it's called the long-shot effect. And let me show a lottery that displays it. Here you have a lottery with probability 1/1,000,000. You get €1,000,000, otherwise you get nothing. My first question to you is, what is your certainty equivalent? So the sure amount that if you receive it, it's just as good as receiving that lottery. And more or less the same as how much would you pay for that lottery. So you pause the video and you think about it. Okay, I assume you made up your mind that you are listening again. I'm curious if your certainty equivalent exceeds 1 or not. Well, the common empirical finding is for most people, the certainty equivalent is bigger than 1, and they are willing to pay more than €1 to play this lottery once. That doesn't mean they are risk-seeking, because the expected value of this lottery is 1, but the certainty equivalent is bigger. They are risk-seeking. Well, expected utility can accommodate that finding, but it has to use convex, or at least in some parts, convex utility to do that. And that is not really good. It's not psychologically plausible, and also in other places it will give wrong empirical prediction. It's really not a good explanation. So, well, you expect it. I'm asking you, how can rank dependence accommodate this finding? And to focus on the novelty of rank dependence, I'm going to ask you, assume linear utility, and then see how rank-dependent utility can accommodate this. So pause the video, and then find the probability weighting function, and when you're done, come back. Okay, I assume you stopped working on it. Then let me tell you the solution that I have in mind. So we have this prospect is preferred to 1 for sure. Well, the rank-dependent utility of this prospect, well, the best outcome is 1,000,000. So we take the decision weight of that outcome probability in its best rank. That is just a W of 10 to the minus 6, yeah? And then I'm not going to write 0. So then the rank-dependent utility of this prospect is W 10 to the minus 6 times 10 to the minus 6. That must exceed 1. Well, I divide by 1,000,000 and I get what I write here immediately. It means that the weighting function at probability P is 10 to the minus 6 must exceed 10 to the minus 6. Must be overweighting there. That is necessary and sufficient to get this done. So that was easy, very easy. You just take any weighting function that satisfies it. For instance, let me show in a graph. Well, it's a bit difficult. 1/1,000,000 is very close to 0, difficult to depict. But if the weighting function is overweighting for the small probabilities, that's enough to give it. And then what it does in the rest of the domain doesn't matter for us at this moment. So almost any weighting function, very easy to do. In a psychological sense, this explanation is plausible. But I think this is really going on. People, they don't understand how small a probability 1/1,000,000 is. If they participate in the lottery, then they think, oh, maybe I will win. And what they are feeling at that word, maybe more like 1/1,000 than 1/1,000,000. So I think this is an important factor in contributing to why there can be a whole lottery industry. And because also other empirical findings, it gives good empirical predictions, it turns out that this is a much better explanation than what expected utility would do. Well, empirically more realistic would be to assume a concave utility function, not linear, but then that would bring in some risk aversion. But then if the weighting function W is sufficiently overweighting the 1/1,000,000 probability, you still get this empirical phenomenon. That's the empirically realistic explanation of it, which is a good thing. Maybe I can also, it's good noting here that we are not finding pessimism here. We are finding optimism. We're finding, because this is not just this, but quite general, we find small probabilities are overweighted, giving optimism. Maybe for specialists, I add, we're talking about gains now. So that is the first papers on rank-dependent utility were written by theoretically oriented people, and also today, many people are still assuming universal pessimism of the weighting function. But that is not what is happening empirically. Empirically is happening what we see here, this optimism for small probabilities is coming in. Okay, so this was another example where rank-dependent utility is working well to bring empirical understanding. More of that to come later.